Okay, today we're going to talk about how to use the trig functions or trig ratios with non-right triangles. So to do this, we're going to need to use a couple of things called the sine law and the cosine law, and we're also going to be able to use the sine and cosine to find the area of a triangle. Okay, so until this point, we've been talking about just simply right triangles when we've been talking about these trig ratios. And at this point, we don't have to anymore because now we have the tools that we can use in order to actually find for just a triangle in general, the lengths or the missing angles or whatever it is that we need. So here's what we got. The sine law applies to all triangles, not just right triangles, and the sine law simply says each of these particular things. Okay, first off, what we've got is we got a triangle that we're going to label A, B, and C with at the vertices, and then on the sides that are opposite each one. So opposite angle A, we have side A, which is a little a. Opposite side B, we have little b, which is the side little b. And opposite angle C, we have the small c that indicates that that line AB is actually referred to as line C. Okay, so what the sine law says is that if you know the sine of angle C, if you divide that by the length of the side C, that has to equal the length, or it has to equal the ratio of the sine B to the length of side B, which is also equal to the ratio of sine A divided by the length of side A. Okay, so in example 1, here's what we've got. They give us some information. They tell us that angle A is 66 degrees, angle B is 32 degrees, and side B is 19. So solve this triangle for the missing angles and sides. So what we have to do is draw our diagram. So what we do is we draw a triangle, and we can make it look like anything we want to, because this time it's not necessarily a right triangle, but they've told us some information about it. So to sort the information out, we just label it A, B, and C, and then opposite each angle we label it with the corresponding side name, which across from angle A is little a, and across from angle B is little b, and across from angle C is little c. Okay, so we put in the information we know, because we know angle A is 66, angle B is 32, and the length of B is 19. So this allows us to set up a proportion. Okay, first off, what we're going to do is to find the angle C, and we do that because since we have two angles, we can find the third angle, because all three angles always have to add up to 180. So C plus 66 plus 32 equals 180, which gives us that C is equal to 82 when we subtract the 66 and the 32 from 180. Okay, then we set up our ratios. Then we have sine of 32, which is the measure of angle B, divided by the length of side B, which is 19, has to equal the sine of angle A, which is measured 66, divided by the length of side A. Okay, cross multiply and divide, and that gives us that the length of A is approximately 32.75. We repeat this with the information to find the angle or the length of C. So the sine of 32 over 19, which this is because these information was given to us, that's why we're using that ratio, is equal to the ratio of the sine of 82, which is the measure of angle C, divided by the length of side C, which if we cross multiply and divide the ratio or the proportion, gives us C is approximately 35.51. Okay, so that's our solution for this particular problem. Okay, it's relatively easy, but here's what one of the problems is. So there is a problem that you have if you have what's called the ambiguous case. This occurs when only two sides in a non-included angle are given. In this event, one of the following is possible. you could have no solution, which simply means that that's an impossible situation. Or you could have exactly one solution because it's a right triangle. But if it's not a right triangle, you will have two different solutions. Okay, this is a problem. So what you have to do is you have to use the cosine law in that particular case. So when you have this situation, you move on to the cosine law so that you can find some more information. Once you find a little bit of information there, you may be able to apply the sine law to finish it out. But here's what we got. The sine law is unable to give a solution when you have two sides and their included angle is the only information that you're given. Okay? In this case, the application of the sine law always results in a single equation in two variables, which means that you cannot solve it. Okay? Because it is one equation in two variables, that means that all progress is going to stop. So that's why we have the cosine law, which comes up and tells us this. This is a derivative of the Pythagorean theorem, or actually the converse of the Pythagorean theorem. But here's what we got. We're told that if in any triangle that the square of the side that you're looking for has to be equal to the squares of the opposite sides squared out minus 2 times the product of the length of the two sides that you know multiplied by the cosine of the angle between them. Okay? So this is the way you should learn it. The square of a side equals the sum of the squares of the other two sides minus twice the product of the other two sides and the cosine of the angle between them. Okay? So that leads us to example 2, where they want us to solve triangle ABC, where the length of A is 5, the length of C is 12, and the angle B is 28 degrees. Okay, so when we put this in here, this is what we get. So as you can see, we've got the information that forces us to use the cosine law as opposed to the sine law because they didn't give us a second angle. So what we have here is the length of B is equal to the square root of 12 squared plus 5 squared minus 2 times 12 times 5 times the cosine of 28. So if you put that into the calculator correctly, that will solve out to be approximately 7.94. Use the ambiguous case of the sine law with either sine of 28 over 7.94 is equal to the sine of A over 5, or the sine of 28 over 7.94 is equal to the sine of C over 12. Always choose the version having the smaller of 5 and 12, and then use the resulting acute angle. Okay, so this gives us the sine of 28 over 7.94 is equal to the sine of angle A over 5. So this means that you cross multiply and divide. That ends up giving you that angle A is approximately 17.2 degrees. Okay, you also need to evaluate what sine 28 over 7.94 equals sine C over 12 comes out to. Okay, because then that will allow you to figure out what you got. Okay, so what they've got here is A plus B plus C equals 180, gives us approximately 134.8, and that's what angle C has to be. Okay, all right. Example 3, we have two observers that are stationed on an east-west line and are 2.3 miles apart. Observer A sees the steeple of an old church with a bearing of north 47 degrees east. Okay, so observer B reports a bearing of north 70 degrees west. How far is the church from B? Okay, so they want to know how far observer B is from the church. So we draw this out. So we've got this triangle. And the way we did this is, notice that what we've got is we got north, and then we measure 47 degrees to the east. That's what they were telling us with that information they gave us a minute ago. Okay, from observer B, you face north and measure 70 degrees to the west. So this means that C is where those two lines intersect. So this gives us an angle on the inside here of the complementary angle, which is 43 degrees to the 47 and 20 degrees to the 70. And we know that the two observers are 2.3 miles apart. So now we can solve this using the law of sines. Okay? So C plus 20 plus 43 equals 180. So if we subtract the 20 plus 43 from the 180, that gives us C is equal to 117 degrees. So this means that the sine of 43 degrees over the length of A is equal to the sine of 117 degrees over the distance between A and B, which is 2.3. Cross multiply gives us that A times the sine of 117 is equal to 2.3 times the sine of 43. Divide both sides by the sine of 117, so A is going to be approximately 1.76 miles. Okay, example 4, they want us to use the parallelogram method to add these vectors. Notice this is the situation where we have to use the cosine law because we have two lengths and the angle between them. Okay, so they want you to find the magnitude and direction of the resultant. This is something that shows up in physics a lot because this is like two forces acting upon an object at the same time. So the way you do this is you construct out the parallel line to the 18 and you construct the parallel line to the 24, and where those meet forms a parallelogram and the diagonal is going to be the result. Okay, so this is what we do. We redraw it so that we get the parallelogram. So this means that you've got a situation here where it's going to come up with this, and we're going to use theta to indicate the measure or the name of the missing angle down here. This is what we're going to need in a minute. Okay, so to use this, we use the cosine law, which tells us that r has to be equal to the square root of 24 squared plus 18 squared minus 2 times 24 times 18 times the cosine of 140. Okay, when we do that, this comes out the calculator and it's approximately 39.52. Okay, then we need to find what the angle theta is, and it's an angle with a side 24. Okay, so the sine of 140 over 39.52, which is what we found in the previous step, is equal to the sine of the missing angle theta divided by 18. Okay. So the sine of theta is approximately equal to 0.292767. So we use the calculator to use the inverse sine function, which tells us that theta is equal to approximately 17.02 degrees. Okay, one other thing that we can do with this is we can find the area of a triangle. Okay, so one of the ways that you can do the area of a triangle is equal to 1/2 of the product of the two sides times the sine of their included angle. So what this gives us is we have example 5 where we have a triangle ABC. The length of A is 3, the length of B is 2, and the measure of angle C is 95 degrees. What is the area of the triangle? Okay, so we draw this out. So this gives us B is equal to 2, A is equal to 3, and the angle between them is 95 degrees. So the area is equal to 1/2 of the length of A times the length of B times the sine of C. So this gives us 1/2 of 3 times 2 times the sine of 95, which gives us approximately 2.99 square units. Okay, that concludes this lesson. Hope you have a great evening. Go ahead and any questions that you have, make a note of them so that you can bring them to class tomorrow, and we will deal with them before we go any farther. Thank you very much. Goodbye.